Now pretend that we've looked at our unit circle and angles on the Cartesian plane, where angles can be bigger than 90 degrees. When we get to functions, we are going to draw graphs of our trig functions. I just want to show you now how we use the idea of the unit circle and that it is actually very much connected to the idea of drawing a function. It's just a different representation of it. So if we have sine, there's our sine graph. We're going to get there. Look at our unit circle. There, if we plug into your calculator, sine 31, it's going to give you a ratio of sides where you have opposite divided by hypotenuse. There's our opposite divided by the hypotenuse, which is 1. It would spit out a value for you, and the value that it is going to spit out is 0.52. Then we plot that. So we plot 31 degrees and we plot that on the y value. So your x-axis is going to be your degrees and your y value is going to be the ratio of sides. So let's go to sine 45, for example, around there. If you put it into your calculator, sine 45 is going to give you 0.7. So sine 45 and then 0.71, and we're there. Then if we get to 90, if you put in 90 into your calculator, it will spit out a 1. And there we plot it. And there we go. In the second quadrant, we saw that the sine ratio will still be positive there. We still form that 90-degree triangle there. Note, if you now put into your calculator sine 126, it will spit out to you 0.813, and you can test that. And that is what we're going to go plot. So now we're going to go plot 126 degrees over there. Obviously, I'm using very weird intervals there. It's nicer if it's like 30, 60, 90, but we're just doing this for the sake of the example of showing how these form. And so it carries on. But then note, when we get to 180, if you put in 180, then over there, it would be your y value that would be spit out over there is 0. And then we plot that. Why is that? Well, sine is equal to opposite over hypotenuse. And in this case, the opposite is 0. The opposite side is just 0. Okay, when we go into the third quadrant, see what happens. We know the sine ratio is negative there because our y value, our opposite, is a negative, and we can see that on the graph. So if we put in sine, let's just get there to say sine 210, it will give us a negative ratio of sides that we need to plot there for our function. And if we get to sine 270, there, it will give us minus 1. Why will it give us minus 1? Because it will be our opposite divided by our hypotenuse, and our opposite being negative 1 and our hypotenuse being positive 1. And then in the fourth quadrant, sine is still negative. There we go. And then obviously we can keep going. There we see, and it doesn't have to stop at 360. We can keep going round and round and round. Then obviously the curve would just keep going, going, going. All right, and the same for our cos graph. There is our cos graph. If you type in cos 0 degrees, it will spit out 1. If you put in cos 45-ish degrees, it will give you that, and then we have to plot that. So we put in the degree and the ratio of sides, and then it forms this curve. In the second quadrant, we saw that cos would have a negative ratio. We saw that, and there we go. So if we plot it, there we go. There's a turning point. There's an intersection with the x-axis, and there it is, positive again. So there we go. And then our tan graph. Okay, goodness, this one is a lot different. Hey, so if you put in tan 0 degrees, then it would spit out a 0, and it will carry on like that. So in our first quadrant, our tan ratio is positive, and if you put in, say, tan 45, it will spit out a 1 for you there. Our ratio of sides will be 1, and whoa, note that there by 90, if you put into your calculator tan 90, it is going to give you a math error. And why is that, Great Danes? Why is it that tan 90 will give us a math error? Because the tan ratio is opposite over adjacent, right? And in this case, our adjacent, our x value by 90 is equal to 0. And remember, we can't have a fraction where the denominator is equal to 0. So it makes it undefined. It is a math error. And then in the second quadrant, our tan is negative all the way down there. And by 180 it cuts. And there it is positive again. And there's another math error where our adjacent would be 0. So we're going to deal with the idea of asymptotes again, just like you did with your functions for your exponential and your hyperbola. And there we go. There it's negative again. And that's it. I know this one is a funny one. We're going to make a little bit more sense of that later when we get to our trig functions. I just wanted to show you the connection with our unit circle.